So welcome everybody to the Voices Distributed Testing Pilot 2 live demonstration. We're here to talk about roughly the culmination of about 3 years of work at FHWA, Federal Highway Administration, along with our research partners. Thank you all for attending today. We're super excited to share with you what we've been working on and to hear from you as well regarding, what you think this could mean for your research and where you see this potentially going. I also want to thank Mcity for being our webinar host today and helping us work through all the camera angles. Quick bit of logistics. For webinar attendees, you will have access to a Q&A box. So please do feel free to engage with it throughout the webinar and you can comment and upvote there. You will not have access to the chat function. And then at the very end of the session, we will have an open Q&A session. So just a quick run through of the plan for this webinar. We're going to go through the background of what is distributed testing, what are the benefits, and what has USDOT accomplished to date with its partners. We'll also go into specifically what Pilot 2 is, why it was created, what it aims to achieve, and what we learned in the process. And then we're going to watch a mixed reality test event in real time with our research partners from across 8 sites. So this is very exciting, and we're really anticipating this being an excellent show. And then we'll follow it at the end with questions. So I do want to acknowledge there are actually a lot of organizations that have helped to make today's live demonstration possible. So I want to do a quick roll call of the major stakeholders we have here. Good afternoon or good morning, depending on where you are. My name is Danielle Chow, and I am a program manager for enabling technologies at the Federal Highway Administration's Office of Safety and Operations Research and Development. I'd like to introduce our Leidos contractor team. If you would come on camera and state your name and title, please.
Yep. Hi, I'm Robin Lequi, project manager for Voices on the Leidos team.
Hi, I'm Andrew Loughran, and I am the systems engineer and test director for Leidos.
Great. And then from the Office of the Secretary of Transportation for Research, can I have you come on camera and state your name and title, please?
Taylor Loughran, Deputy Director and Chief Scientist here at the Haas COE.
And Joshua Every, also with Haas COE as a senior scientist.
All right, excellent. And then if it's okay, MITRE, if you could come online and introduce yourselves as OSTR's contractor team.
Hi, Kevin Long with MITRE. I'm the technical lead and lead developer on the Voices platform.
Great. And then moving along to the Intelligent Transportation Systems Joint Program Office at DOT.
Hi, everyone. Brian Cronin, Director of the ITS Joint Program Office. Happy to be here today.
All right, great. Thanks, Brian. I think at this point, we're going to switch over to the Department of Energy partners. Will the folks from the Vehicle Technologies Office turn on your cameras and unmute yourselves to state your name and title, please?
Hi, folks. I'm hoping my camera's on. I'm not seeing myself, but I don't need to. Okay, thanks for the thumbs up. I'm Austin Bowen. I direct the Vehicle Technologies Office here at the Department of Energy. I believe my colleague Lexus is also on.
Hi, all. Alexis Zubro, Program Manager, the Energy Efficient Mobility Systems, and glad to be here.
Great. Transitioning to the other DOE folks, can I have Argonne introduce themselves?
Kevin Studenberg. I am the Group Manager for the Advanced Mobility Technology Laboratory here at Argonne National Laboratory.
I'm Debashish from Argonne National Lab. I'm working as a postdoc here and I'm working in the Kevin's group also. Thank you.
And Miriam, Vehicle Research Engineer at Argonne National Lab.
Great, perfect. Oak Ridge National Lab.
Here's 9 years old R&D associate staff at Argonne National Laboratory, and in our team also got Ross, Aiden, and Jinghui.
Hello, everybody. Ross Wong, Oak Ridge National Laboratory. I'm a group leader here.
All right, now we're going to go to the academics. Mcity, will you please introduce yourselves?
Henry Liu, Mcity Director, Professor at the University of Michigan.
Greg Stevens, I'm the Research Director at Mcity.
Hi, I'm Derek Johnson. I'm the Principal Engineer at Mcity.
All right, anybody else from Mcity? Okay, moving along to the University of California, Los Angeles, UCLA.
Good morning, good afternoon. Jiaxin Ma. I'm Associate Professor at UCLA, also Director of Mobility Center of Excellence. I have my team member Xu Han here as well. Xu.
Yeah, hey everybody. Xu, I'm graduate researcher at UCLA.
All right, fantastic. Econolite, kick us off with the industry intros.
Hi, I'm Andrea Schumacher. I am the senior engineer on the SQA traffic team.
Great. And Volkswagen.
Hi, this is Omer Ibrahim. I'm a senior V2X systems integration engineer at VW Group of America. Thank you.
Great, thank you, Omer. And bringing us home, Traffic Technology Services, also known as TTS.
Hey everyone, myself Vanil Shah, traffic engineer at Traffic Technology Services, now part of MyVision.
Right. And I think that is all the intros. So thank you, everyone. As I mentioned, these are the folks we've been working with for roughly the last 6 months. So they're critical stakeholders, and I wanted to make you all or give you everyone a chance to introduce themselves. So I want to note that the brief today is very Federal Highway Administration focused, but this project was done very much in collaboration with the Office of the Secretary. So I want to give OSTR a chance to also make some opening remarks. Taylor, do you want to say anything?
Yes, of course. I just like to say this is a very important milestone and exciting day. Wow. I mean, 4 years ago, we really pushed the limits of bringing this technology from a different part of the federal government into the Department of Transportation. And as you can see, we're already cross-cutting partners and stakeholders from all over the country that see value in these tools to help us really evaluate highly automated systems. So we're very excited about this today, about seeing the experiments today, and more excited about what we're going to do moving forward. So just wanted to start with that we're very happy to be here, and thank you so much to Federal Highway for all your leadership, Danielle and Brian and others that really helped pave the way for this technology to be a valuable asset and tool to the department and to all of our stakeholder community. Thank you.
All right, thank you, Taylor. And I do want to also acknowledge the presence of Martin Knopf, our Associate Administrator for Operations at FHWA. Unfortunately, with the mad scramble with the links, I didn't give him the panelist one, so he can't come off mute, but thank you, Martin, for being here today as well. All right, to get us started, just a quick disclaimer. So you're going to hear the names of manufacturers and organizations and simulation products over the course of this presentation today, but they are included for informational purposes only. This is not an endorsement of any products or manufacturers by the US government. So why are we here today?
Sorry, are you sharing your screen?
Ooh.
It might
I
be
knew
helpful.
this was gonna happen. Thank you, Robin.
No problem.
We're a good tag team.
Here you go.
All right. Thank you. Okay, so why are we here today? Really, this was an acknowledgement maybe about 5 years ago within the US Department of Transportation. that the transportation system is getting increasingly connected. It's seeing, not only the traditional OEMs and the traditional infrastructure owner operators, but also, the introduction of new players from the tech sector. And what we're seeing is that there's a multiplicity of stakeholders here who have different ways of doing things. They use different language, different vocabulary, they have different interests, and they weren't used to working with each other. And so there were natural silos and trust deficits and, a healthy sense of competition sometimes. So the U.S. Department of Transportation asked ourselves, like, what can we do to help facilitate these connections in order to make sure that as systems come online, and they're integrated into the overall transportation system, that they're done in a safe and interoperable way. Keyboard seems a little slow. There we go. All right. So that's why USDOT created Voices, the Virtual Open Innovation Collaborative Environment for Safety. And Voices is a mixed reality, geographically distributed network platform to do interoperability testing. So I just said a whole bunch of jargony words, but the gist of it is that essentially you can have partners from multiple locations connecting and testing their elements in an interactive way, whether they be simulated or physical assets. So the example I like to give is that, for instance, you could have a projection level vehicle today that is now interacting with a 10G radio that doesn't exist yet, except as a few lines of source code. And you can do this to test out concepts and to work out ideas, as well as to do integration testing. So what does it take to do?
Danielle, I'm sorry to interrupt again.
Yep.
A couple of chats coming in that they're unable to see your slides. Wondering if
they should be showing now. If folks in the Q&A could confirm, they should be seeing them.
Yes, we can see that now.
Okay, great.
All right, so I'll just pause and wait actually until.
Yeah, we have several people saying they can see the slides.
Okay. Are we good now?
Yes. Yes.
Yes.
Okay. All right. Sorry about that. And thank you, Calvin and Robin, for pointing that out. So what does it take to do a distributed test? There are really 4 elements. The first is that you have to have a secure network to make sure all of the research partners are able to connect and test securely and reliably. You also need this common language so that when you are exchanging information, you know in what format it should come through, and how to interpret the data. So that's what we're calling our TINA tools, the Test and Training Enabling Architecture tools that we've actually tech transferred from the Department of Defense, which has invested in these technologies and tools for over 20 years. The third element you need is a common scenario, which helps to define the test, and it makes sure that all your test partners have a shared reality during the test. And then last, you need the test elements. And so these can be physical or simulated, they can be under human or automated control, but the thing they must all have is a digital representation that we can watch during the test. And all of this is actually very efficient because the only things that we pass around during the test are ground truth states and message data. So your test element is effectively a black box to everybody else, which helps protect IP and in case people wish to do so. So the benefits of distributed testing we think are multi-purpose. The first is we believe that you can reduce costs because you can flag issues and resolve them early in a virtual environment before you've gone to a test track, before you've potentially poured concrete or bent metal. The other thing you can do is reuse models because our goal here is to enable everybody to bring the tools that they've already invested in and reuse them when simulating with other people. The third point is we want to facilitate collaboration with others and kind of accelerate the behavioral norms and harmonization that comes with a very diverse and multi-agent ecosystem. And then the last is we want to protect intellectual property while making sure everyone is securely connected with others. So you'll have heard me mention both voices and distributed testing sometimes in the same sentence. For those of you who've been following voices for the last 4-ish years, you've also heard that voices was tech transferred. So what is the difference? Well, I want to highlight here is that the U.S. Department of Transportation has been involved in both halves of these capabilities, right? So the way we would define it is voices is the test network on which we're doing the testing. And OSTR has been technology transferring that and working with MITRE to build and operate it. While distributed testing is the capability that FHWA has been focusing on to perform these geographically distributed tests using mixed reality tools. So the tech transfer of voices will result in the end of a contract for USDOT in September 2024, but distributed testing will continue because we believe it is a very useful tool in helping address certain types of research and development questions. So the analogy I like to make a lot of times is like voices is like the internet, while distributed testing is like applications and websites on the internet. You need both, and they're very closely related, but they're not exactly the same thing. And one thing I do want to highlight, actually, is that Pilot 2, which you're going to watch today, is important because it represents the convergence of these parallel paths. We're going to do distributed testing in real time on the Voices portal, which shows that both of these things are happening together. All right, now we're going to talk about the testing that FHWA has done to date. My colleague Robin is going to take over at this point. Robin, are you there?
You're on mute, Robin.
Sorry, wouldn't let me unmute there. I don't know, Zoom crashed and came right back. So apologies. All right, so testing to date. Demo 0. This was 2 years ago. We performed Demo 0. I think a few of you were actually there, but this was really our first step in showing that distributed testing with a common middleware was going to be possible. For this demo, we took a live vehicle driving at Turner Fairbank Highway Research Center, and we were able to get it represented in simulation over a network. And it was a blending of live and simulated elements that are able to sort of interact with each other and test together. So it was really sort of the start of it all. The next test that we did was actually only a few months later. It was quite a bit more complicated. For this test, we connected 3 sites over the secure network, 2 in Virginia, 1 in Georgia. We conducted a mixed reality test involving a live vehicle again, and 2 fully simulated Karma vehicles, as well as a human-driven simulated vehicle. So a person with a steering wheel driving a car around in the sim. There were 3 phases. Phase 0 was really just making sure everyone was connected and staged properly. In phase 1, we exchanged operation messages over the network to form a moving platoon with a live vehicle in the front and the 2 simulated vehicles following behind. For phase 2, we had the platoon encounter a work zone where the infrastructure was sending out messages received by the vehicles over the network, and the platoon was able to perform a slowdown based on these received messages. And so that was really demonstrating how infrastructure can work with vehicles in this platform. And then finally, for phase 3, we demonstrated that a live vehicle could interact with a connected traffic signal, which really kind of paved the way for our next pilot test, which we called Pilot 1. Pilot 1 took a little longer to put together because we engaged with more external partners for this go around. So it was April 23. This test was entirely simulated, and we connected 4 sites using, or we connected the 4 sites to test sort of non-karma based models. Previously, we'd been doing mostly karma. So this pilot test was really designed to collect data to inform an SAE standard for assured green period. The 4 sites we connected were FHWA, sort of representing the government, Nissan in Michigan as an OEM, Econolite in Ohio, now California as industry, and UCLA in California as academia. The test had 4 sequences, which I'll cover real quick. Test 1, Nissan drove a kinematic vehicle model through an Econolite controlled intersection for this data collection. Test 2 had a vehicle receive standard messages and was able to perform a stop at the intersection. And test 3, we added a UCLA vehicle, which was also able to receive standard message and interact with the intersection as well as the other vehicle. And then finally, for test 4, we switched to a digital twin of an intersection in Los Angeles, which UCLA provided us with. And we tested UCLA's perception model and added the element of potential conflict where cars, may or may not run into each other. So all of these sort of building in complexity, leading us to today.
Yep. So you'll see that there's been an evolution both in the number of partners that we're testing with, going from just local area network to point across 3 sites to 4 sites, and now today 8. And then also increasing complexity and incremental development when it comes to the diversity of models. For us, starting with all karma, the FHWA developed cooperative driving automation suite of tools, but then progressing to include non-karma tools and even potentially other simulation platforms. So then that brings us to today, as Robin described. So I'll do a quick overview of each of the events that were involved in the Pilot 2 test campaign, and then we'll do the demonstration. So overall, the goals of Pilot 2 were to make sure we were studying and demonstrating how to do distributed testing for different connected and automated transportation applications. And it was really important to us that we co-develop and execute the objectives and concepts of operations for these tests with our research partners. So every step of the way, we were talking with everybody to understand, what did they want to accomplish? How might we work together? What would we learn that would benefit us all from working together? And that really informed how we put together the tests and how we executed them. We also, again, as I mentioned, we wanted to use the Voices portal, which had by then become recently available to us. And all of this, testing that we're talking about happened within actually a very short period. So within FHWA, we started planning probably about 8 months ago, and then we held our first stakeholder meetings back in September. And, by November, we were testing, December, we had another test, and then March 29th was our last event 2 test before we prepared for this demonstration today. We have videos that summarize our previous testing events. They're listed here on the slide. And we also actually have a technical report for the Systems Integration Test 1 that has just made its way through the DOT public release process. So we can share more information about that soon so that you can read it for yourselves. In the meantime, we're also working on technical reports for both pilots 1 and 2 that will also be publicly released. So the objectives that we and the partners came up with together were really focused around 2 different categories. We have co-simulation objectives and we have application objectives. The co-simulation objectives were about making sure we could connect multiple sites using a cloud-based network, and that we could demonstrate how these diverse models and tools could work together. We also wanted to make digital test assets, including scenarios, maps, adapters, analysis tools, and more. We wanted to make those available to all the test partners and the broader community. On the application side, it was very important to us that we study problems that we believed would help accelerate the technical maturity of different safety and efficiency enhancing cooperative driving automation applications, or CDA. And we wanted to make sure we were testing different algorithms from diverse sources to ensure that they could work together safely and interoperably. And it was an opportunity for us to identify, where do conflicts arise? Where are there pain points, right? Where is there friction in the system? Because that is the area where we think there could be a lot of value added doing in the virtual space. We also really wanted to support the use of standard message formats to help us kind of converge towards what could be a potential deployment pathways. And then we also really wanted to work together more closely so that we understand, what are the research questions that are important to academics and to industry and government. So I mentioned that Pilot 2 was a test campaign consisting of 3 events. Event 0 is what we call the connectivity test, and it happened in November 13th. Keeping in mind, we just started meeting as a full partners group in roughly September. So this was pretty fast. And then event 1 happened less than a month later, and that was the interoperable vulnerable road user sensing message test, which we'll go into more detail about these. And then lastly was event 2, which happened on March 29th, and we described that as our collaborative eco-driving test. And that is the one that you're actually going to see today with some augmentations from event 0. So I'd mentioned, we're doing distributed testing, but I don't think anything describes it more powerfully than looking at a map, right? And you'll see that this test includes partners from all across the country and even internationally. In the government space, we have our research facility at Federal Highways, the Turner Fairbank Highway Research Center, which is based in McLean, Virginia. We have Argonne National Lab based in Illinois, and then Oak Ridge National Lab based in Tennessee. On the academic side, we have Mcity, which is based in Michigan, and then UCLA out in California. And then on the industry side, we've got Econolite, which was in Toledo, Ohio, but Andrea Schumacher, who's here with us today, she's actually based in Anaheim, California. And then we've got Volkswagen in California and Traffic Technology Services, or TTS, based in Beaverton, Oregon. So I will mention TTS is actually operating a machine that's sitting in Oregon, but the person controlling that machine is actually sitting at a desk in Edinburgh, UK. So truly we're demonstrating that this is not just national, but international. I do want to highlight that Pilot 2 was possible because we were able to leverage the capabilities and investments made across multiple organizations from academia, industry, and government. And I'm not going to go into the specifics of every block here, but I do want to highlight that every single research partner brought its own unique contributions to this test campaign. We have a digital twin from Mcity. We have 5 different simulated vehicle models, all different, all distinct from various partners. We have also a live vehicle on a chassis dynamometer test stand in Argonne today. And we've got a live vehicle that's driving around on a real test track at Mcity, also live today. Our testing included virtual pedestrians and virtual traffic signal controllers to represent what is possible and available in the field. And we've got tools that are potentially, these operationally deployable pathways to help us understand, can these be used, what kinds of applications are feasible or viable with these other pathways. And then we've also got analysis of how US-based standards compare to international ones. So with that, I'm going to hop to Pilot 2 Event 0, and Professor Jiaqi Ma from UCLA is going to give us a quick introduction.
Sure. So I'm going to go ahead and talk about Event 0 of Pilot 2. So the first thing of Event 0 is to include a new digital map. So we got Mcity digital maps from our Mcity partners. They are here as well. I'm going to talk about what Mcity is. Everybody knows about Mcity. But it is important that Mcity provides such a great variety of testing scenarios, I think, and more importantly, once the team has been testing this map, kind of go back and forth, corrected issues that on this map, from transferring it from a high resolution map to a digital asset of voices, then this becomes a very valuable asset for any future type of testing. So what some of the examples are that through the numerous testing that we were able to correct the locations of stall bars, locations of infrastructure like traffic signals, and so on. This will be very critical in a joint testing environment like voices. Next slide. The part 1 of Event 0 is replay of Pilot 1, which happens last year, as Daniel just introduced. So the research question is, can multiple sites simultaneously co-simulate and interact with micro traffic across a cloud-based network? So there's a lot of information in this sentence, but basic idea is that in Pilot 1, we're using the OpenCDA vehicle in UCLA. If you're not familiar with OpenCDA, it is really a connected autonomous driving platform. So we focused on how to include V2X messages into a true autonomous driving platforms, how to integrate that messages to autonomous driving. But anyway, so the UCLA's OpenCDA vehicle was first spawned in this Mcity map, which is our new environment. We did a lot of testing to ensure that the maps, the OpenCDA vehicle is able to operate on this vehicle as an autonomous driving platform, including perception, decision-making, and so on. And then Econolite as infrastructure, as traffic signal infrastructure, they were here also in the joint testing of Event 0. They provide infrastructure messages, standard messages that the UCLA's OpenCDA vehicle was able to receive. And then, our focus is testing if we can receive that message and in this environment, and also using our own platform to be able to respond appropriately. Last but not least is that for the first time in the voices testing, that the Sumo was used. The Sumo's purpose is to include the traffic, background traffic. All of us know that background traffic plays a very critical role and will contribute a lot of different scenarios. So Sumo is also a tool. There's a lot of its own confounding lane change models that included. It's very suitable for generating different types of traffic scenarios. So Sumo was used, and later you will see that how we're using Sumo to generate different scenarios, including using the TerraSim software from Mcity. Next slide. The part 2 of Event 0 is really the first time that all the 8 partners that you see on this map come together. They each spawn a car vehicle or their own vehicle, right? And then operate in this joint environment. As you can see here, Sumo traffic was generating background traffic in UCLA. I think FHWA, Volkswagen, these are the simulated vehicles using different driving platform, different vehicle models in there. And as Daniel mentioned, Argonne has a dyno, and also Mcity has a real vehicle operating, and which is also synchronized in this environment. In this initial Event 0, we didn't do joint testing, but later others will talk about joint testing of autonomous automated functions. But this one, we focus on setting this foundation, right? How to synchronize all these vehicles together. We ask all the partners to using manual control, using simple manual control commands as you shown here, the 6 commands. And then the purpose was testing the functionality of the Voices platform by itself, about the delay and what's the performance of synchronization. And after different runs, we're able to come to a state that we believe that the Voices platform is ready for the next steps of testing.
All right, thank you, Jachi. At this point, I'm going to play just a quick video of what happened during Event 0, and our test director for all of the distributed testing events that we've ever held, Andrew Loughran, is going to walk us through the major highlights and what to watch for. Andrew.
All right. Yeah, so thanks for that great intro, Jachi. Here we can start with our lovely participants here. And as we get to this here, we can see the Sumo vehicles starting on the left side. You can see the Sumo vehicles go across in the Sumo on the right and Carla simulation in front of you. The green vehicle is the Open CDA vehicle. You can see them approaching the traffic light, and now they've stopped at red, waiting for green, and now they're progressing through. So again, this is a pretty simple test here, just rerunning things in a new place with the new map, new traffic signals. So this was a great baseline test for us as we got our testing started. And you'll see we zoom out here and we have all of our different participants here for our big manual vehicle event. And so now you can see them all on the left, all of the red highlights there, and we're off. And each vehicle is going to drive around a loop here. You can see some Sumo vehicles in the background. They'll make one big loop and then they'll return back to this final starting position where we began. And like Joshi said, this was a really great exercise for us. We were able to actually identify an issue with the, excuse me, identify an optimization we could make with the Carl adapter, which interfaced with all these different driving vehicles and actually increased the efficiency greatly because of this test. So it worked out really well for us and was a good stepping stone for the rest of the events coming up.
All right, thank you, Andrew. And I will say there was probably some mildly friendly competition happening during the what we called Midtown Madness race. All right, so now we're going to talk about the details from Event 1, what we call the interoperable VRU sensing message test. And here to dive into it more deeply is Derek Johnson from Mcity.
Hello again. So my job today is to introduce Event 1 to you, and as soon as I'm done with that, we're going to show you another video of the test in progress. I'll start with the participants. We have the Federal Highway Administration, Mcity, Volkswagen, and Traffic Technology Services. Each one of us played a different role in tackling the research question in play, which is how compatible / interoperable are these two very adjacent sensor sharing message standards. So we've got SDSMs, which is short for sensor data sharing message, and the cooperative perception message standard that ultimately VW was going to take a look at how compatible those two are. So we started at Mcity. We have a system out on our facility doing object detection, perception, and localization, and then that gets translated into SDSMs. We recorded that so that we could replay it at a later date to kind of up the efficiency of working with so many different partners and not have the test facility in play. That's something we're doing right now with Mcity 2.0 is trying to take out the test bottleneck and move more towards a digital twin, more towards simulation. So we collected that information, and then I wrote 3 or 4 scripts to parse those messages and then replay them as if they're happening in real time. So we reconstructed those messages for the participants, and there were 3 types. There was signal, phase, and timing for the lights at the intersection. There was obviously the SDSMs coming out of the perception system, and then there was also map information to give you the road geometries of the intersection. So all of that was being reproduced in real time. and VW and TTS were listening in. TTS used that data to visualize the signal phase and timing using their PSA tool. So it was a nice visualization. We had that off to the side while we were running these so we could get visual confirmation that yes, indeed, all that data was moving through the voices communication backbone and getting to everybody in real time. And then VW was collecting and storing that information to do offline studies about compatibility. And we look forward to the document findings from VW. And I think that covers event 1. So without further ado, I think we'll move on to the video.
All right, thanks, Derek. I do want to highlight, like, the SDSM is an SAE standard, whereas the cooperative perception message is from the European Telecoms Standards Institute. So this is an opportunity for us all to, also to harmonize internationally and see, how well does one standard map to another, and whether or not we can, there's any room for convergence there. So with that, let's take a look at Pilot 2 Event 1. And again, Andrew is going to come on camera and walk us through what exactly happened. Andrew?
All right.
Ready? Okay.
Ready. Okay. So, as mentioned before, on the left, we have the TTS PSA tool, which is showing the live traffic signal states coming from the SPAT information that's being replayed by Derek at Mcity. And then on the right side, you can see the Carla interface for the same intersection. I think we'll change angles here in a second and you'll get a little bit better perspective on, yep, you can see the traffic signals here. You will note we're only showing phases 2 and 4, 6 and 8, the major straight and right turn directions here. But you can see as the traffic signal updates, it matches with the display on the PSA tool. So now we're going to start replaying the SDSM data, and you'll actually see a visual representation of the pedestrian crossing the stream on the Carla interface. Right here, you can see that red box. This is a replay of data that was collected, as Derek mentioned, is himself, I believe, crossing the intersection from one side to the other. So we replayed the crossings all the way around in both directions, and kind of showed what, a very quick mock-up of the, display of these messages might look like in simulation here. And I think that's it.
All right, thanks, Andrew. And I do want to highlight, right, like most of the testing that you're seeing today is what we believe to be groundwork for future types of tests. So you could envision how potentially in the future, someone could bring in a vehicle model that would then see when you receive an SDSM, how does the vehicle respond? Is it able to avoid the pedestrian or the VRU or whatever else is in the intersection? Likewise, how does a vehicle respond to the cooperative perception message standard, and what is the relative performance between those two standards? Which one, is there one that's more effective? We don't know the answers to any of these questions today, right? But that's part of what we're proposing are the types of questions you might be able to answer in such a simulation environment. So now on to Pilot 2, Event 2, the event you've all been waiting for. We're going to have a quick explanation of what happened from Kevin Stutenberg of Argonne National Lab. Kevin.
Right, thanks, Danielle. So Event 2, the collaborative eco-driving test, arose from the desire of the Voices participants to answer the research question, how might surrounding traffic challenge the assumptions each vehicle makes when they are optimized for eco-driving? So to demonstrate how the Voices platform could be used to answer this question, 6 participants from all across the country and notably behind different firewalls came together for the real-time test, each one providing a mixture of real or simulated actors. So those participants included Argonne National Laboratory, Econolite, Federal Highway, Mcity, Oak Ridge National Laboratory, and UCLA. The test took place at Mcity in both real and simulated worlds and included both vehicles and infrastructure. During the test, Econolite broadcast intersection, SPAT, and map messages to a real Mcity vehicle on their track, to a heavily instrumented real vehicle at Argonne, capturing energy use data in a controlled environment. That was a chassis dynamometer, and simulated vehicles that were at Federal Highway, Mcity, Oak Ridge, and UCLA. Additionally, TerraSim, Mcity's naturalistic driving environment that can also be turned into an adversarial driving environment, provided simulated traffic. So during the test, all the participants collected vehicle operation and energy use data, whether they were live or simulated. Next slide. Thanks, Danielle. Here you can see the now familiar bird's eye view of the Mcity test track with the location and the starting lineup of all the vehicles for event 2. The vehicles proceeded on 2 paths, with the simulated TerraSim vehicles providing traffic while driving on independent routes that you can see in green. Meanwhile, the mixed fleet of real and simulated vehicles drove on the red loop. The Econolite controlled cross intersection marked the path of the northbound TerraSim 2 vehicle and the eastbound vehicle string. So the test procedure for event 2 was first repeated 3 times for each vehicle individually, and then 3 times with all vehicles together with the following steps. So first, the vehicle or the vehicles would stage at the edge of the data collection loop. They would then start and accelerate to 10 miles per hour before they entered the data collection loop. The vehicle would stop at the green signalized intersection within the data collection loop as directed by the signal. And once the intersection allowed, it would proceed on the green and complete that full data collection loop. Next slide. During testing, key data and energy metrics were captured to allow for both real-time and post-processing analysis of the energy impacts. So at Argonne National Laboratory, a heavily instrumented vehicle, like a heavily instrumented real vehicle running in the controlled laboratory environment of the chassis dyno, it provided the real-time data on both vehicle operation and energy use. Meanwhile, the simulated vehicles that were at UCLA, Oak Ridge, Federal Highway, and Mcity collected speed trajectories and road grade that was based on their location on the Mcity map during the event. That data from those simulated vehicles was then combined with the vehicle type and in post-processing fed into Argonne's autonomy tool to provide an estimated energy use that was specific to each participant's vehicle. So there are a few notable caveats worth mentioning during this test. First, due to schedule constraints in both the real and the simulated worlds, each partner did not focus on running their best eco-driving algorithm. Additionally, during event 2, test speeds were limited to 10 miles per hour. A low speed, or 10 miles per hour is a low speed that really makes pulling noticeable energy benefits from the vehicle's controls challenging to outweigh against like any test-to-test variability that you would see. So nevertheless, the test definitely demonstrated a full process to evaluate the original research question that we had using voices, and whether the vehicles were real or simulated or on-road or instrumented or in a controlled testing environment. So now for the fun part in mixed reality. Thanks, and back to you, Danielle.
All right, thanks, Kevin. And there was a point that Kevin made that I wanted to make sure we all didn't miss, is that we're not running our best eco-driving algorithms today. You know, this was just a proof of concept to show like how we would do this, because the priority for the Pilot 2 test campaign was really schedule, right? Schedule and resources, like how can you bring what you've already got with minimal development and still make it a really useful test? So with that, I am going to stop sharing my screen and we are going to do the live demonstration. So live from all across the country. Andrew, take it away.
All right, great. So as you can see here from those other views, we now have our Mcity view live. This is running on my machine here. And you can see each of the participants on the screen here as well. So starting from the front of the line here, we have UCLA's Open CDA. Then you have Argonne's dyno vehicle, Oak Ridge's eco algorithm vehicle, Mcity's mixed reality live vehicle, and then the FHWA Karma platform vehicle, which is actually running on my PC locally. You can also see down at the bottom the TTS vehicle down on the south side, and then the VW all the way on the right side. They'll be participating as bonus vehicles, as Danielle mentioned. In order to kind of incorporate all the events together slightly, we added the TTS and VW manually driven vehicles. They'll be driving around just as additional background actors. on top of the Terracin vehicles, which we don't see them yet, but they will spawn in, drive their route, and then when they get to the end, they will actually despawn. You can also see the Econolite traffic signal changing. We have the visual representation shown here in text, just because from this angle, it's really hard to see the lights. And yeah, that's going to be all of our participants for today. Everybody was getting ready in the background, so we're pretty much ready to go. The next portion. Oh,
pardon the interruption. We also have live feeds from infrastructure and the dash cam on the Mcity vehicle, and I believe we have a feed of Argonne's vehicle as well. Is that correct?
That is correct.
Yes.
Okay,
So
excellent.
You're right. We can see on Derek's view, we can see the dash cam and the chase cam, which is really cool to see those update as the live vehicles go through. And then we also see the ANL dyno is the view of the cars, and you'll make sure to watch for the wheels spinning and everything. It's pretty exciting. Okay, so our start is based on timing of the traffic signal because we want to make sure that we stop at that red light. So I think we just missed our opportunity for this run, so we're gonna have to wait another 50 seconds or so for the lights to cycle through. Andrea, can you give me a 10-second countdown when there's 10 seconds left in green on phase 2 and 6?
Yep, we got a few seconds here before it changes to the phase of interest. So it'll be another 30 seconds or so.
Sounds good. And then we'll drive our loop, and I'll narrate as we go. So about 15, 20 seconds here on your marks. All right. Everyone knows time goes slowest when you're waiting at a traffic light, right?
10 seconds left.
All right, everybody, we're going to engage in 5, 4, 3, 2, 1, go.
UCLA engaged.
All right. And we're off. We can see the UCA vehicle take off, as well as the Dyno Argonne vehicle behind. And then Mcity and FHWA have the most, give the most generous space between other vehicles here. So you'll see them start up once the vehicles leave their designated safety buffers. You can also see the VW vehicle starting its route across. And you can also see the Terracin vehicle spawned in and has approached the traffic light and stopped at red. And then once that turns green, it'll go across, and we can switch views here. We can switch to a chase cam view here of the FHWA vehicle, and we can follow the string as we go down the road.
And that swerve you saw was for map, due to map artifacts. So consider it a virtual pothole.
Yeah, just the curvature of the road. We can see the yellow TTS vehicle approaching here. Pretty soon we'll start to see the red Terracin vehicle that's now gotten the green light and makes its left turn. TTS is gracefully waiting for us to cross the intersection. And we can also see the vehicles kind of lining up at the traffic light, waiting for green. Car platform's not doing a very good job not blocking the box, so that's okay. Okay, we've gotten the green and we'll progress through. You can see the other Terracin vehicle on the top of my screen here as it goes and finishes its route on the lower section of the track. Now we'll go around and make this turn here. I'll switch back to this view. We can see TTS has been freed up and is now finishing its route over on the left side, and the Terracin 2 vehicle finished its route on the right side.
And you can see the dash cams also from Mcity, right? There's I think a cell phone feed in there as well.
Yeah, I was just going to point out that I don't know if anyone caught it, but you could see the live vehicle drive by on the chase cam as well from the from the traffic signal poles. Kind of cool.
Yeah, so all of this is happening in real time across these 8 sites, integrating both that mix of simulated and live test assets.
All right, we'll switch back to the chase cam here for the final stretch.
And you can see the last intersection being passed at Mcity there with the car.
Yep.
Yep.
Entering that roundabout, exiting the roundabout at this point.
And the wheels on the dyno moving because the car's moving.
Yep.
Getting ready to stop.
All right, and then all the other vehicles have reached their destinations. Car and platform's going to end up right here in the middle of this roundabout, and that will be the end of our test.
All right, that's a wrap. Thank you, everybody. I think we want to take a moment here to pause. A lot just happened within the last few minutes, and ask our audience, do you want to see this again played as a video? Because we can go through it again and kind of highlight the events that happened. Because otherwise it takes actually a few minutes before we can reset everything to run again. So in the interest of time, we figured we would just play a video. If you're interested in watching the replay in the video, please raise your hands, attendees.
Yeah, we've got 2 or 3 raised hands so far.
All right, so I think I'm gonna go ahead and play the video. Andrew, if you don't mind doing the voiceover again. So this
Yeah,
is
of course.
okay. So this is a run taken the week of, I guess technically April 5th, and I mean, these folks made it look really easy to make the test happen, but this really required a lot of work in making sure that we had the coordination across all the sites. You know, you may have heard Andrew talk about raising your hand and lowering your hand. You all can't see that as attendees, but that is the process by which we have learned how to do coordinated distributed testing in a very efficient way. So with that, I'm gonna go ahead and play the video. Andrew, if you wanna do the voiceover.
Danielle, you just need to share your screen.
Oh, good call.
All right. So we'll just go through the first half of the loop here, which is the exciting part. And then once we get around the corner, we'll probably switch over to the end of the presentation and some Q&A. All right. So as we mentioned, we have all of the different distributed testing applications happening here. UCLA OpenCDA, they're our leaders for this test. Argonne has developed their following algorithm as well to follow them. And if I remember correctly, Argonne, Oak Ridge, and UCLA all enhanced their platforms during this test event to actually use the BSMs and SPAT, the J2735 messages, in order to both understand where other vehicles are as well as adhere to the traffic signal. So, you know, we talked about standardized messaging before, so that was another huge feature for us that we were able to kind of share with everyone. So we're off here again. We dodged this invisible pothole here as we go down our main loop. You'll notice we don't have VW and TTS on this one. This was just the regular event 2. And we were also able to use this this time to even do a couple runs with the UCLA Eco Approach algorithm, which was developed using on the platform and tested with the entire string as well. So here we are approaching the traffic light. and you'll see the TerraSim Vehicle 1 this time approaching on green. They're just going to make a left turn from the Econolite traffic light while the string kind of settles in at the intersection.
You may notice as well that the dash cam portion that you can see, it's actually raining at Mcity. So
It's snowing.
Snowing, sorry. So
Yeah.
we get to do this in all sorts of weather.
Right, and then all the string settles in here, and we get the green light. We leave through the intersection. Then shortly here, you'll see the TerraSim 2 vehicle start its route, which will run parallel to the string, going the opposite direction.
Yeah, and unfortunately the camera cropped off the wheels of the dyno, but you'd be able to see it rolling along as well.
Yep. All right. And at this point, we now have all the vehicles through the intersection. Both TerraSim vehicles have started, and the remainder of this video is simply the vehicles finishing their routes. So I think that was the exciting part. So I'm not sure if we want to finish the video at this point. I think it'd be time to move on to the rest of the presentation and questions.
Yep. Thanks, Andrew.
Yeah.
So I'm just going to keep letting the video play. All right, so I'm going to let the video play, but I also want to highlight an observation I think that UCLA made, which was that the 3 vehicles, UCLA, Argonne, and Oak Ridge that are at the beginning of the string, those are actually all simulated vehicles. And so I think UCLA had observed that they seemed to be tuned more aggressively relative to the Mcity and the Karma vehicles, which are really derived like hardware-based platforms, right? Hardware-based platforms with digital representations. And so that's also an illustration of what this kind of transition from simulation to real world is, right? You know, what are the things that you find along the way as you're introducing increasing fidelity of the tools and introducing more realism to, for instance, the simulated test assets. So I think we're gonna pause here for a moment and see if any of the Pilot 2 test partners want to comment on their experiences doing these runs, some of the other observations that were made, and then we'll wrap it up with kind of a description of the upgrades, findings, and fixes that we made, and then close it with a Q&A at the very end. But I just want to pause for a moment to give people, our partners, an opportunity to comment. So like Henry or Greg or Jachi or whomever wants to comment, feel free to do so at this time.
Just want to comment that this is a great teamwork, and Mcity has learned a lot through this collaboration with the national labs, Federal Highway, and other partners. And so,
hey Henry, I'm sorry. For me, at least, you're a little hard to hear. Can you speak up a little bit?
All right, can you hear me now?
Yeah.
Okay, I just want to say we learn a lot from this collaboration together with Federal Highway and also other partners in this process. I think this is a great platform, and this really demonstrate in the future in terms of distributed testing.
All right, great, thank you. Anybody else want to talk? Otherwise, we'll move along. No pressure.
I'll hop in and say, hey, Danielle, this is Kevin Stutenberg from Argonne. I definitely like to commend everybody who is really the boots on the ground in getting everything going. I know there were a lot of hours and kind of getting things prepped and ready and running the demo, getting 6 different participants to all work in line. You know, if you've got everybody in the same room, it's challenging sometimes, let alone if they're all across the United States. So nice work to everybody, and thanks, Danielle, for your direction in getting this going.
All right, thanks, Kevin. Yeah, I mean, this really would not have been possible without everyone's patience and their talents. And the hardest part of it was actually aligning all of our schedules. I do want to also mention, right, like this kind of testing is not to be undertaken casually, right, but very purposefully. What are you trying to answer? Why does it require multiple sites or multiple test partners? And that makes, when you ask yourself those tough questions at the beginning, that makes the testing much more fruitful. So with that, I think we are going to move to our Pilot 2 summary. All right. So Robin, you want to talk about the upgrades, fixes, and findings?
Sure. Thanks, Danielle. So research is never complete if we don't reflect on what we've learned. By executing Pilot 2, we've collectively improved our systems and our knowledge in many ways. Some of the upgrades were to digital assets, such as the Mcity map. Numerous improvements were made to that map to have it work for us. We updated several systems to use standard messages where they may have been using custom messages on their own. But when you're working with other partners and collaborating, you all have to use standard messages. So that was that allowed us to do some expanded testing of eco algorithms with UCLA and Oak Ridge running their own eco algorithms and really across standard messages. Some fixes that we've done. Federal Highway, the Karma vehicle, we tuned on that quite a bit to get the yielding behavior to work properly and improved its object detection. The Voices portal itself now allows for different protocols, communication data exchange protocols, TCP and UDP. So some improvements were made to the portal itself through findings of our testing with lots of people. And they're still working on improving the built-in data visualization to better allow observers to see what's going on and see some of the data during the testing. There were lots of findings as in addition to the fixes and upgrades, probably too many to list. You should be able to read about them in the Pilot Test 2 report that will hopefully be coming out shortly. We're working on creating a report for all of this that we hope to publish. A simple example, which I think Danielle mentioned earlier, was simply having partners raise their hands when they were ready or when they were connected, just indicating that they'd be able to move on to the next step. We learned that kind of just in doing these sorts of tests. Another more complicated one is that we found things like the Karma sensor model was sometimes treating moving vehicles as obstructions instead of vehicles. And so that allowed us to make some improvements and develop the Karma platform to operate better. So these are examples of how this kind of testing with others really leads to improvements and more efficient development of your products or your things. So hopefully that helps to explain, you know, what we really learned during performing these tests. Thanks, Danielle.
All right, thanks, Robin. So we're going to close out, or getting close to close out with a summary. All right, so what was Pilot 2? Hopefully by now you'll remember Pilot 2 was a test campaign of 3 different test events across 8 sites that was conducted within a span of roughly 6 months. For each of these tests, you know, we leveraged the existing simulated and physical test assets that our various research partners had already built and invested in. And we streamlined these testing processes to make it easier for us to work together. We were able to talk about and potentially identify, you know, where there were potential conflicts. You know, Robin talked about that tuning between vehicles. And I think that was true for all of us. You know, everyone had to adjust their vehicle a little bit to accommodate all these different vehicles that were all behaving differently. And we wanted to show how this could help facilitate the development and maturation of standards and norms. I hope all of our partners had a good time, you know, and they learned a lot in this process, because that was also a major goal. And we are anticipating the release of the Voices and Distributed Testing version 1.0 license and those associated terms of service, hopefully by early fall of 2024. So we talk a lot about technology when we do these things, but we cannot stress enough that what makes it possible are the people. And to all of our test partners, thank you so much for your patience, for your talents, and for just your knowledge and enthusiasm and helping us make this a reality. Because when we first started talking about, you know, doing a distributed test with all these partners, we're like, do you think we can get all these people to agree? And do you think we can answer questions that this group of stakeholders is going to care about? And the answer, I think, has been yes. And, you know, we really appreciate all of you, and we hope that, you know, you will continue to pursue this kind of testing when it makes sense for each of you. So, you know, if there are any questions about Voices and distributed testing at DOT, please feel free to contact me. Again, my name is Danielle Chow from DOT, Federal Highway Administration, or you can email voices@dot.gov. At this point, we're going to open it up to questions. So, Calvin, if you don't mind, making sure potentially we have people coming off mute. So I can't see the chat box.
Yeah, so I'll read the Q&A, but yeah, if you're interested in speaking, you can raise your hand and I can temporarily unmute you. We do have one question in the Q&A that I can just read out to you.
Okay.
As a total novice, this demonstrates to me the potential for the massive integration needed for full network operations, but it must depend upon a huge amount of data flowing on many paths. Does this project also estimate the needed bandwidth and latency and reliability required for a region-wide network?
Thank you, Jesse. That is a great question, and one that we have also keenly been interested in. The demonstration you saw today actually did not include any test data recording, but we have done that previously in all of our prior events, so that we can understand, you know, when you have this amount of data flowing through, what should we expect for those latencies? And what should we expect depending on where the cloud servers are, right? And depending on where the test partners are. So I think at this point, we're still, this kind of testing is still in its infancy. So we are definitely studying and quantifying and measuring those metrics, so that we understand, you know, what are the implications, both from a standpoint of like, what applications can we do on here, and what kinds of requirements might a site need to fulfill in order to test. Any other additions to that answer, Robin? Robin Long?
I was just going to add that really we've tried to design this, that it's pretty lightweight. And we definitely, in doing partner tests with 8 participants, we've learned where some bottlenecks are and have been able to unblock certain things. But there should be no reason why we wouldn't be able to test and scale up from here. We just haven't done it yet.
Go ahead.
Yeah, and just to kind of add on to that, I mean, as the Voices platform evolves and matures, I mean, there are plans to do, you know, some of that planned testing of the platform in terms of what it can handle, but also to provide instrumentation integrated into the platform to allow users insight into the amount of data that is flowing through there, things like latency, system performance, user performance, et cetera.
Thanks, Kevin.
I would also like to add, we did do some initial analysis on this exact question in the SIT1 report, which is now publicly released. So that's a really cool place to go look. It's a little different data architecture than we're doing now. We made some changes, and there's all the details on that in the report itself. But if you want a number, just off of what the high level analysis was, it was about 100 to 150 kilobytes per second per vehicle. So that's, again, where we are now with the test platform. But if you were just looking for perspective and the lightweight stuff, and that's, you know, sending maybe 20, 30 messages per second per site. So
thanks, Andrew. And Andrew mentioned the lightweight platform. I think that's something we should highlight. I can't remember if we talked about at the very beginning of this brief, but it was a question that came up a lot in the early days of the Voices project, which is how are you going to have, you know, like what are the bandwidth requirements going to be if everyone is simulated in that same simulation environment, right? In one, we'll call it master brain, right? And that's not the way Voices works. The way this works is, like I said, we pass around only ground truth data and message data, and then everything gets rendered on the edge. So everybody is running their own versions of Carla in order to see what's happening, and also to reduce the amount of data that is required to pump through the network.
We have another question in the Q&A, Danielle. Can you describe what happens in the event of a failure? How does the system facilitate a graceful recovery?
All right, I'm going to turn that question over to Andrew because we talked and planned for this multiple times.
Absolutely. So given the developmental nature of the system in its current state, I would say it has room to grow in the restart functionality. Currently, right now, the way the system works is you all come up, you know, everybody joins in. If you've seen other demonstrations, you might have seen the vehicles kind of start from a high point, and then when they spawn in, they drop in as their own physical vehicle is spawned into the simulation. Right now, if a vehicle was to crash, you would have to restart all of the different sites and then come up gracefully once again. But at this very moment, we are working on the enhancement that we've been designing with our team over the past couple of weeks, which will allow for people to drop in, drop out. And, you know, timing's unfortunate, but we do plan to have that ready to go and tested in the next few weeks. So future events will have the functionality to simply drop vehicles in and out. If, you know, someone has a startup failure, or, you know, let's say someone has to leave in the middle of a test, they can just come in and out as they need.
And
if I can add,
yeah,
sorry, Danielle, if I can add to that, that is why this thing exists, is for failures, right? So as you develop your tools, you want to be having these failures. This is why we're prioritizing this graceful drop in and drop out. But thanks, Andrew.
And the graceful drop in and drop out is so that if one partner has a problem, everybody can still keep moving forward. But what we've really focused on is like the simulation aspect of this. But we haven't even mentioned, you know, what happens in the event of a crash when it's in the physical world, right? And this is where there's a lot of benefit to, or we believe there's a lot of benefit to what we're doing, because nobody is ever hurt if there's a crash and you have learned something, right? You've learned something about your ODD or your algorithms or your perception system, right? And that's all incredibly valuable to find. And I will say, like, for those who came to our March 29th official run for record, it was rough. It was like really rough compared to today. And we had a vehicle crash and a vehicle that went like somersaulting and flying through the air. So this kind of virtualized testing, I think, is incredibly useful in that regard. Are there any other questions?
Just an add-on, it's also a fraction of the cost to
Yes.
crash here than elsewhere.
Yeah, and nobody's hurt ever, right? Like that virtual, or actually the virtual pedestrian we saw in event 1, right? That was Derek walking around on the intersection, but he got to stay nice and cozy and safe in his office cubicle while we were testing with his dummy.
Yeah, we have another question, Danielle. What future research questions are you hoping to unlock with the Voices platform? And what do the industry partners see as the benefits or challenges of using something like Voices?
So actually, I want to pause on this question and see if there's anything our test partners want to say about this. So I don't see the question written in the chat.
It's
but-
it's in the webinar chat.
Okay.
Yeah, it's not in the Q&A. My apologies.
Okay, that's okay. All right, so do you mind copying it, Calvin, into the regular Q&A so everybody
Yeah,
can see it
absolutely.
and everybody can get a chance to take a look at it? Yeah, so I guess while we are doing that, the question is about, what other types of research questions we think could be answered here. I think we have our own ideas. There's definitely something about interoperability of different algorithms. About better integration, using this as an integration tool as we're getting closer to product, development and deployment. But we'd love to hear what you all think, right? So feel free at this point, feel free to raise your hand because we can unmute you if you want to respond. And then likewise for the panelists, feel free to jump in.
Hey, Daniel, I just want to kind of express my thoughts about this question a little bit. I'm all about future research questions. I think that tools like Voices is kind of what we have done so far, right? Is laying a foundation, proof of concept, showing it works. But to me, to enable a testing, so there's a lot of performance of the tool itself need to be fine-tuned, not even fine-tuned from a software perspective. There got to be even algorithms that help better synchronization. I think the research on that itself is even research, right? It's not just like fine-tune the software and make it work, or adding like empirically adding 1 second, maybe there's some AI algorithm that helps you capture the delay and then compensate for it. So there's a lot of things him to do. This is going to be very interesting work. And we have never mentioned in this, or we mentioned a little bit about interaction of these different partners. I think that is a core of tools like Voices, because these different people will interact, so different vehicles will interact with each other very kind of, there might be unexpected behavior coming out of it. But that will also build upon very good performance of the tool itself. Last but not least, I want to mention that it is the Voices distributed concept to me, because we are talking about CAVs, CDA, cybersecurity is a big topic, and whole distributed concept or decentralization is actually a very effective solution to this kind of cybersecurity issues. So Voices tools like this, right, will protect everybody's not intellectual property, but also can be a tool to showcase some of the effectiveness of decentralization for improving cybersecurity. So that's kind of the immediate thoughts when I see this.
Yeah, that's a great point, Jachi. And potentially, actually, the original idea for Voices was that you could use it for cybersecurity testing between different types of elements.
Danielle, I wanted to jump in. Hi, everyone. I'm Michelle Michelini at MITRE, and I didn't introduce myself earlier, but as this question is coming up, we are collecting a number of use cases to inform the next step of development for Voices as we continue to enhance it and evolve it over time. And we have lists of use cases. In fact, we're hosting a number of AV developers this week for an InfoShare session, and Voices has come up a couple of times in those discussions. So we're excited to see where it evolves. And I know Danielle, and supporting you these past few weeks as we've gotten here, we're super excited to see the demo work today and work really well and continue to evolve. So we'll take any and all use cases to sort of get a prioritized list of the demand and begin to figure out next steps. So just wanted to jump on and encourage that.
Thanks, Michelle. And I know like we have presented on voices and distributed testing at various conferences, including TRB. And that is one of the topics that comes up, right? Is how do I find other partners to work with on the kinds of testing I'm interested in? And so we're still working through like, and you know, we want to be able to help facilitate and grow this community so that you know, collaborative research can be done amongst anybody, right? It doesn't have to involve FHWA. We love to be a part of it, right? But we recognize there are many other partners. They're also doing extraordinary work. So we want to be able to help connect all of you as well. Yeah. Yes. Are there any other questions, Calvin? I just want to make sure I'm not missing anything.
Yeah, nothing in the Q&A box. Again, if you do raise your hand, we can temporarily unmute you and you can ask your question if you'd rather do that.
Hey, Daniel, can I just add one point to what you just described? I think now we have 8 partners. It's already a big number to us from the beginning. But I think tools like this, voices like this, needs a community. So even in NSF today, they have dedicated programs called POSE to develop open source platforms ecosystems. I think it's probably one of the necessary steps is the develop this community of practice and also community of content contributors, you know, for voices, right? You know, like Mcity Maps is like our core partners, but there's a lot of other things that, you know, in this digital asset of voices need to be contributed by the community, not just by, you know, the eight partners here. It's impossible for us to do everything. Yeah.
Yeah, I completely agree, Jachi. And we've talked about like, how do you scale this so that we can leverage on what these 8 partners have accomplished, as well as what the Voices Minimum Viable Products Working Group has accomplished. Because that group included DSpace. I think Ben Hager was here earlier, and Larry Head as well. I think he's still online, or he was. But you know, we're only, you know, onesie twosies, right? So we want to figure out how to help others find this capability and test for themselves. There was a Voices community of practice earlier. I think it's kind of in an evolving state. So, you know, stand by or please stand by and, you know, follow what happens with that, because we hope that that will be the nexus of where all these conversations are converging.
And then now since we are Build a Foundation, it's time for content contributors. So those people gotta come in. So we have a more open environment that people like GitHub, right? You know, that's what we use usually. People can contribute to assets, to their own model zoo, you know, or anything.
Yep, absolutely. All right. Any other questions or comments? I see like there are several folks from throughout USDOT who are present. I don't know if anyone wants to comment now that we're at a point where we can unmute you. If you want to comment, just raise your hand, your virtual hand.
I wouldn't mind taking this moment just to say that, you know, we've heard a lot about what the partners are doing, and that's primarily because Danielle was a gracious host, but also a driving force and a lot of optimism from her. I want to recognize Danielle and Robin and Andrew for all of their work and their central role. It was really a Herculean lift to get all of us together, all of us communicating. There was a lot of stuff going on behind the scenes that wasn't exactly readily apparent, and on purpose, because that's what you do with a good demo. But the 7 or 8 different technical stacks all combined together in one place, running smoothly, that's not easy, and that was a Herculean lift. So thank you for all of your time and effort, and it was really great working with this team. This was a really special team. So with that, I'll close out.
Yeah, thanks, Derek. It has been super fun, and hopefully all of you felt the same way. I really enjoyed it. I hope Robin and Andrew have as well. And I know we talk about this project a lot because we enjoy it so much.
Alexis, I see your hand.
Yeah, Alexis, you have your hand up.
I wanted to ask a question about where you think it is in terms of ease of entry at this point. I know there was a lot of work in terms of trying to help these initial partners kind of get up and running. Where in terms of maturity do you think it is like it now if we had another university who wanted to join or another industry partner who wanted to join? Like, is it just in kind of broad brushstrokes, like how hard would it be in comparison to, or how easy would it be in comparison to how hard it was at this earlier stage in these earlier events?
Yeah, that's a great question. I think like it depends. So this is not just your casual person who's hoping to install something and just run, right? We're not at that point. Everyone here who's been a research partner is a technical researcher. That said, we've made the process easier and easier. So if they're already doing modeling and simulation, we think that it should not be a huge lift with the assistance of documentation, as well as the community to get up to speed. So hopefully that answers your question, Alexis.
We'll jump in on that one too, Danielle.
Yeah, I mean, from a platform perspective, the platform is there. I mean, from a onboarding of connecting your entities, you know, kind of circling back to what Danielle had said earlier about community, and somebody had mentioned like the GitHub model of sharing things, right? So part of the community aspect is, you know, from an adapter perspective, if you've already adapted and built an adapter that hooks up Carla to voices and speaks Tina and whatnot, being able to share that within the community, you can now start to share those types of adapters with others to make that connectivity easier. So, you know, as progress happens, you know, being able to share within the community makes onboarding easier for the users, so that, you know, it really does become, you know, use this tool, you know, use this other thing off the shelf and use this other thing off the shelf, and you can very easily get connected from a connectivity aspect. From a platform, the platform is there. It's kind of a blank slate in terms of what you want to do on top of that platform. And that's where the adapters and the different type of entities and how you want to connect that and scenario orchestration and whatnot starts to build on top of the platform itself.
All right, thanks, Michelle and Kevin. So we are pretty much at time. We're actually a few minutes over, but I really want to thank everybody for joining us today. You know, we appreciate your interest, and hopefully we can answer any questions you have. And thanks again to all of our partners and to and our stakeholders, and to Mcity for hosting this webinar. So thank you all and have a great rest of your day. Bye.